Hi, you guys. Today you are working on prime factor trees. So this relates to finding the greatest common factor. Notice that you have 18, 28, and 34, and then all these other floating numbers. So you're going to do a factored tree with each one. So the reason we call it a tree is because it looks like we're drawing branches out from the number. And the reason we call it a factor is because factors are numbers that multiply and give me the numbers you see here. So I'm just going to do 18 for you. The reason I drew two of them, I'll show you why in just a second, is because there are multiple ways you can do this. So please make sure you watch this whole example before you get started. So you're finding numbers that multiply and give me 18. Well, I know that 1 and 18 gives me 18, but then I'm still going to have to keep factoring out 18. So don't do the factor of 1 in itself. That's not going to help you because we already have 18 to begin with. So I want you to think of another math fact that gives you 18. Your goal is to do the greatest one, the greatest math fact, because we need to branch it out. So I'm going to go with 9, and I know that 9 times 2 is 18. So now what you do is you need to look for prime numbers. What are prime numbers? Prime numbers are numbers that only have a factor of 1 and itself. So 2 is a prime number because the only numbers that multiply and give me 2 are 1 and itself. So that's a prime number. So what I'm going to do is I'm going to circle it because that one is done. I can't factor it out anymore. Once I get a prime number, circle it and it's done. I'm not going to factor it out anymore. 9 can still factor out. I have other numbers that multiply to 9. I have 3 times 3. Can I branch out my 3's? No, 3's are prime. So that means my 3's are done. I don't have any other numbers to factor out. So how do we write down the prime factorization? It would be 3 times 3 times 2. 3, 3, 2. So you're trying to get down to all of your prime numbers and then you're done. Now, I'm going to show you that you can still get the correct answer if you started with a different math fact. What if I did 6 times 3? 6 and 3 gives me 18. 3 is a prime, so I can circle it. I can factor out 6 still to 2 and 3. 2 and 3 are both prime, so I'm going to circle those. And notice I get the same answer. I have 2 times 3 times 3. So this proves that even if you do a different math fact, either 9 and 2 or 6 and 3, you should still end up with the same factorization answer. So I'm going to do another one for you guys just to help you out. Let me do a bigger one like 34. I'll do 34 for you. I know that 34, let's see, what's multiple of 34? And what if you're not sure? Well, can you do 34 divided by 2? Let's find out. 2 goes into 3 one time. 1 times 2 is 2. I subtract and get 1. Bring down my 4. I know that 17 and 2 give me 34. So, and 2 goes into 14 7 times. 7 times 2 is 14. So 17 and 2. Okay, 2 is prime. Do you guys think that 17 is prime? It is. So my answer is just 17 times 2 for my prime factorization. Okay, you guys, so I want you guys to go ahead and work on this, the rest of the sheet, and then, of course, bring it to school, and we'll see how you did. All right, talk to you later.